Today we are writing more equations, but we are writing equations of parallel lines and of perpendicular lines. Okay, so parallel lines are two lines that never intersect. And they never intersect because their steepness is the same. So parallel lines have the exact same slope as one another. Now, the y-intercepts will be different, but they're going to have the exact same slope. So the only way lines never ever touch is if their steepness is the same. So parallel lines have same slope. Now, perpendicular lines, these are two lines that intersect and make 90-degree angles. Well, their slope are opposite reciprocals. So perpendicular lines, their slopes are opposite reciprocals. Now, if you have had me before, you have heard this song. And if you haven't had me before, you might have heard it because I might have talked another teacher into singing it to you. Okay, so this is one of my songs that I created several years back. And it's to the tune of Hickory Dickory Dock. So I'm going to sing it to you. Parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. That means flip and switch. Hey, that means flip and switch. Yeah, flip the fraction, switch the sign. Now you've got it. So this song really tells you about parallel lines and perpendicular lines, and it tells you how to find opposite reciprocals because sometimes students struggle with that. So I'm going to sing it again. Parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. That means flip and switch. Hey, that means flip and switch. Yeah, flip the fraction, switch the sign. Now you've got it. Okay, that's my song. All right. So you may not remember every word of the song unless you sing it over and over, but hopefully there's a few things about it that you remember. Okay, so first of all, I want to practice what opposite reciprocals are. So if I gave you the fraction negative 2/3, I want to figure out what its opposite reciprocal is. So my song says, flip the fraction, switch the sign. Okay, so let's ignore the sign for right now. So I'm going to flip the fraction and then switch the sign. So if it was negative, it becomes positive. And if this one was positive, then this one would be negative. So that's what opposite reciprocals look like. So you take one of the fractions, you flip it over, and switch its sign. So flip the fraction, switch the sign, now you've got it. Okay, let me make up another example. Let's just say I gave you the number 4. Okay, first of all, you have to remember that every number is understood to be over a 1. So if you want the opposite reciprocal, you're going to flip the fraction, switch the sign. So if this one's positive, this one's negative. So these are examples of opposite reciprocals. Okay, so we're going to do a lot of what we did in the previous lesson, but we are going to be writing equations that are parallel to something, or we're going to be writing equations that are perpendicular to something. Okay? All right, so in all of these problems, I am going to be using point slope form that we used the other day, and then we're going to convert it to slope intercept form. All right, so I want to write an equation of a line that goes through this point and is parallel to this line. Okay, so let's think about my song. Parallel lines have same slope. So what's the slope of this line right here? This line has a slope of -2. And I know that because when it's in y equals mx plus b, the slope is the number smushed against the x. Okay, so let me show you a symbol for parallel. This is slope, and then parallel is two straight up and down lines. So this is saying the slope of the parallel line is also -2. And that's because parallel lines have same slope. So whatever this line has a slope of, the parallel has to have the exact same slope. All right, let's see if we are ready for point slope form. Do I have a point? Yes, right here is my point. And do I have a slope? Yep, I know my parallel slope is going to be -2. So I'm ready to go. Okay, so today I'm not going to write the equation down. Let's just get to it. So it goes y minus the y coordinate. So which one's the y coordinate? 1 equals your parallel slope, -2, and then parentheses x minus the x coordinate. And which one's the x? -4. Remember, the minus the negative back to back makes a big old plus. Now let's clean it up. So let's distribute to get rid of the parentheses. So -2 times x makes -2x. -2 times 4 makes a -8. Bring down your y minus 1. And then what do you think you do? Add 1. To get rid of subtraction of something, we add. So we're going to add 1 to both sides, and things start dropping like flies. Drop the y, drop the equals, drop the -2x, and then calculate. What's -8 plus 1? -7. Okay, so this equation here is parallel to this equation here because they have the same slope. Parallel lines have same slope, but they're not the same line because their y-intercepts are not the same. And this equation specifically goes through this point and has the same slope as this guy. See, a lot of what we did before, you just needed to know a little bit about parallel and perpendicular. Okay, let's try number 2. So I want to be parallel again. So what's the slope of this line? 3. The slope is the number in front of the x. Okay, so I want to be parallel. So slope of the parallel. Parallel lines have same slope, so whatever this line has a slope of, parallel has to be the same. Do I have a point and a slope? Yes, I do. Here's my point, here's my slope. We're ready to go. Y minus the y coordinate, -3, equals your slope, and then parentheses x minus the x coordinate. Remember, the minus the negative back to back makes a big old plus. Minus the negative back to back makes a big old plus. Okay, let's distribute. So 3 times x makes 3x, and 3 times 2 makes 6. Okay, drop down your y plus 3. And now to get y by itself, what are we going to do? Subtract 3. To get rid of addition of something, we subtract. Okay, that zeroes out. Drop it down. Drop your y. Drop your equals. Drop your 3x. And then what's 6 minus 3? 3. And that's our equation that goes through this point and is parallel to this guy. And sure enough, they do have the exact same slope. Okay, let's try perpendicular. So this time I want to be perpendicular. So what is the slope of this line? -2. Okay, so let me show you the symbol for perpendicular. So slope, it's an upside down T. This is the symbol for the slope of the perpendicular line. Now remember, -2 is the same thing as -2 over 1 because every number is understood to be over a positive 1. So think about the song. Parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. Okay, so this time I want the opposite reciprocal. That means flip and switch. Hey, that means flip and switch. Yeah, flip the fraction, switch the sign. So what do you get if you flip the fraction and switch the sign? A positive 1/2. Because if this fraction is negative, this fraction's positive. Okay, I've got my point, I've got my slope, and I'm ready for point slope form. Here we go. Y minus -1, that's the y coordinate, equals my perpendicular slope, 1/2, parentheses, x minus -6, because that's the x coordinate. The minus the negative makes a big old plus. The minus the negative makes a big old plus. Now let's distribute. What's 1/2 times x? 1/2 x. Now what's 1/2 times 6? Now this is easy to do in your head. What's half of 6? Half of 6 is 3. And if you had to, you could practice this alpha y equals. So alpha y equals, hit number 1, 1 on top, arrow down, 2 on bottom, right arrow out of the fraction, and take 1/2 times 6. And sure enough, it's the 3 that we said it was. Okay, let's bring down our y plus 1. And then to get y by itself, what would we do? We'd subtract 1. Okay, so at this point, the y drops down, the equals drops down, the 1/2 x drops down, and what's 3 minus 1? 2. And that's our answer. Not so bad, is it? Okay, this next one, I want to be perpendicular again. So what's the slope of the line they gave us? 1/3. So I want to be perpendicular. So let's figure out the slope of the perpendicular line. So parallel lines have same slope, but perpendicular lines have slope that is opposite reciprocals. Okay, I want the opposite reciprocal. That means flip and switch. Yeah. Hey, sorry, I forgot my song. That means flip and switch. Yeah, flip the fraction, switch the sign. Now you got it. What do you get if you flip the fraction and switch the sign? -3. And I can put over 1, but -3 is the same thing as -3 over 1. Okay, so I'd rather have it look like this. So now we're ready. We've got our point and we've got our slope. So here we go. We go y minus 6, that's the y coordinate, equals our perpendicular slope, parenthesis, x minus -2, because that's the x coordinate. The minus and negative back to back makes a big old plus. All right, let's distribute. -3 times x, -3x. -3 times 2, -6. Drop down your y minus 6. Now what? Add 6 to both sides. Things start dropping like flies. So I'm going to drop the y, drop the equals, drop the -3x, and then what is -6 plus 6? 0. Well, I could put plus 0, but I don't have to. This means the same thing. And there's my answer. And this line goes through that point, and it is perpendicular to this line right here. And that's because their slopes are opposite reciprocals. What do you think of this lesson? Not bad? Okay, now these next two problems are really easy. Number 5, it wants me to write an equation of a line that goes through the point 2,5 and is vertical. Okay, all these other answers that we've got, do you notice? X, Y, X, Y, X, Y, X, Y. Well, what does that make? X and Y makes a diagonal line. X and Y makes a diagonal line. These are all diagonal. Well, this doesn't want diagonal. It wants vertical. So, I'm not thinking about y equals mx plus b anymore. I'm thinking about hoy or bucks. So if I want to be vertical, I want to be bucks. Vertical line, undefined slope, x equals for the equation. So it's x equals, and then which of these is the x? The 2. And that's my answer, and I'm done. Okay, this next one, I want to go through this point, but I want to be horizontal. So if I don't want to be diagonal, I have to be hoy or bucks. Well, who's horizontal? Hoy. Horizontal line, 0 slope, y equals equation. So it's going to be y equals, and then which one is the y? -2. And that's my answer. Okay, I'm going to skip number 7. It's just more of what we were doing earlier. Now, 3 more. I want to write the equation of the following lines. So you see a diagonal line, a vertical line, and a horizontal line. So if it is vertical or horizontal, it's either hoi or vux. Who do you think this one is? It's a vertical line, so it's going to be vux. So it's going to be x equals, and then what is your x everywhere right here? You are left 1, 2, 3, so your x is a -3 everywhere on that line, and that's its equation. So this guy, since it's horizontal, must be hoi. So that means it's going to be y equals. So y equals, and who's your y down here? 1, 2, 3, 4. It's a -4. So that's your equation and you're done. Okay, now number 8 on the other hand is diagonal. So if it's diagonal, then that means it needs to look like y equals mx plus b, right? Because x and y makes a diagonal line. So if it's diagonal, we have two things to figure out: the slope and the y-intercept. Okay, so let's do it. So let's start with the y-intercept. The y-intercept is wherever the graph is touching the y-axis. And where is the graph touching the y-axis? At a +3. So this is going to be a +3 in the back. And then the x just recopies, the equals recopies, and the y recopies. Now I need to figure out my slope. So remember, we find slope by counting our rise over our run or our fall over our run. So I like to go from left to right. Just going to zoom in a little bit. Okay, so I rise up 1, 2, 3. So my rise is 3. And my run is 1, 2, 3, 4. Now, if I could reduce this fraction or divide it out, I would, but I can't, so that's my answer. So if an equation is, or if a picture is diagonal, a diagonal line, then you have a little more work to do. Find your slope by counting rise over run, and find your y-intercept, which is where the graph touches the y-axis. And that is all for this lesson. Smiley face.